Okay, welcome to this video, and it's going over the solutions to the maths preparation sheet part 2. And what you'll notice on this particular preparation sheet is that the topics are getting a little bit more challenging, and that's because on the second half of the maths paper, more of the A and the A star topics appear. So for more information on this one here, go to clip 188. So the information that we're being given here is that P is inversely proportional to V. So we would write that P is inversely proportional. So if it's an inverse proportion, we would write 1 over V in this case. So it's inversely proportional to V. In other words, P will be equal to something over V. And it's this something here that we need to find in order for us to write an expression for P in terms of V. What other information are we being given here? Well, we're being told that V is equal to 8 when P is equal to 6. So we can now substitute those values in for V and for P into this expression here. So we will end up with 6 equal to K over 8. And we can now solve this to find the value of K. So what do? Well, we would multiply 8 by 6 to get the value of K. So K would equal 48. So in other words, the expression that we're looking for P in terms of V, it would be P is equal to, and we put this 48 now in here for the K, 48 over V. And that's the expression that we are looking for. Part B then is asking us to find the value of P when V is equal to 2. So with inverse proportion, if the value for P goes up, then the value for V goes down, and it works in that way. So P is equal to 48 divided by V is the expression. We know that V is equal to 2. So what we're going to do is we're going to substitute 2 into the expression, into the formula here in the expression. So it'll be 48 divided by 2, and 48 divided by 2 is 24. So P will be equal to 24. Okay, simplifying an algebraic fraction. Before we go into the nuts and bolts of how to do this, really what we want to try and focus on is our general rules for fractions. So if I was to write down 3/8 take away 2 over 11, for example, as a numerical problem, how would we have to go about this question? Well, as we're subtracting fractions, what we would need to do is we would need a common denominator. So we would find something that 8 and 11 go into. In this case, it's 88, so 8 times 8, giving us 88. So on the bottom of our fraction here, we would have 8 times 11 to give us our 88. And to work out then the change of the numerator values, we would multiply 3 by 11, and we would multiply 2 by 8. So we would cross multiply in here. So we would end up doing 3 times 11 minus 2 times 8. So in other words, it would be 33 take away 24 all over 88. And we would write that as one fraction at the end. And this is what we're being asked to do here, is to write this expression here as a single fraction. And so we need to consider the technique that we would use for numbers. So first of all, what we would need to focus on here is what would the denominator be for here? Well, in order to get this, we would need to multiply the denominators together. So by doing that, I would have to multiply 3x minus 5 by 11x minus 13. Now on the numerator, now what we would need to do is we would need to do our cross multiplying. So I would need to do 2 multiplied by 11x minus 13. So here be 2 lots of 11x minus 13. Take away, because the problem is asking us to take away these fractions. And then I would have to multiply 7 by 3x minus 5. So there's my numerator. Now I need to tidy that up now on my numerator. And so I would need to expand both of the brackets. So on here, I'm expanding this bracket by multiplying through by 2. So 2 times 11x, 2 times 13. So here I've got 22x minus 26. Oh, I've got to be really careful on this one because in front of the 7 is a minus. So we're going to multiply everything in the bracket here by minus 7 or negative 7. So first of all, then minus 7 times 3x gives me minus 21x. And minus 7 times minus 5 or negative 5, the two negatives will multiply and change to a positive. And 7 times 5 is 35. And again, we would just write that all over our common denominator that we found in the first place of 3x minus 5 multiplied by 11x minus 13. Now you can see now we've got 4 terms on the numerator here, and we need to simplify them. So I'm going to collect together the terms that contain x. That's 22x, take away 21x. So in this case here, that leaves me with x. And separately, see, I've got minus 26 and positive 35. So either doing minus 26 plus 35 or 35 minus 26 gives us positive 9. So gives us positive 9. And that's our numerator value simplified. That's all over 3x minus 5 and 11x minus 13. And that's how we simplify an algebraic fraction problem. Okay, in this question, we need to form and solve a quadratic equation. So I'm being given some information here. First of all, it's telling me that the sum of the areas, so that's adding together the areas of these two shapes here, A and B. When I've done that, is 44 centimeters squared. So we are, from that information, going to have to show that 2x squared plus 3x minus 44 is equal to 0. Now, if I'm going to do area on these shapes, then I multiply length by width. So on this first one here, I would work out x times x. So on shape A, x times x gives me x squared. And on this second shape here, this rectangle, I'm going to multiply x by the x plus 3. So x multiplied by x plus 3 is a bracket I would need to multiply through. So I would multiply through by x, so x times x gives me x squared, and x times 3 gives me 3x. Now, because we said the sum of these areas, that means I'm going to add together this area here of x squared, and this area here of x squared plus 3x, and they're going to equal 44. So I got x squared plus 3x is equal to 44. Now, I collect together my x squared here. So I've got x squared plus x squared, which is 2x squared. I've got my 3x. And when we're solving these types of problems, we want to make the right-hand side of the equation equal to 0. So I'm going to take that 44 away. So if I take 44 away from the right, I've got to take 44 away from the left-hand side of the equation. And that gives me 2x squared plus 3x minus 44 equals 0, as I was asked for. Okay, for part B, then we're asked to solve this equation and to find the length of rectangle B. Don't need that little bit for that. So, because this is a non-calculator question, we need to consider here a factorization method to help us solve this equation. So, how do I make 2x squared? Well, in my bracket, I need a 2x and an x. I know I need two brackets on this question because there's no common factors to take out at all, so it's not going to be one bracket. Now, when I multiply these two together, I get my 2x squared. But the number part that goes here and goes here, these two numbers need to multiply to make 44. So I know that could be 1 times 44, could be 2 times 22, or it could be 4 times 11. And when I expand the two brackets, this number here is going to be multiplied by the 2x. So I know that one of these pairs of numbers is going to be multiplied by 2. I also know that by here, that the minus 44 tells me that when I multiply the two number parts together, I'm going to get a negative outcome. It means the signs in the brackets are going to be different. So it means I'm going to have one positive sign and one negative sign. At this stage, I don't know which bracket they're going to go in. And because I've got different signs, when I've worked out my 2x times this number here and my x times this number here, they're going to have a difference of 3x. So in this case, now it's a question of playing around with it. So multiply 1 by 2 gives me 2. So 2 and 44, does that have a difference of 3? No. If I was to multiply the 44 by 2, I get 88. Does 1 and 88 have a difference of 3? No. So we can ignore that one. We can rule that one out. And do the same with this one. So if I was to multiply this 2 by 2, I get 4. Is the difference between 4 and 22 3? No. And I rule that one out. And if I multiply the 22 by 2, that gives me 44. 44 and 2 have a difference of 42. So I can rule that one out. So it leaves me with the 4 and 11. So if I multiply 2 by 4, I get 8. 8 and 11, that's definitely a difference of 3. So I need to be choosing 4 and 11. Now, we were multiplying 2 by 4. The 4 goes in here. And so the 11 goes in here. Now, when we've got 8 and 11, the way to make positive 3, if I did 8 take away 11, gives me negative 3. Well, I don't want that. I want it to be 11 take away 8 to give me positive 3. So it's going to be take away the 8. So 2 times minus 4 gives me my minus 8x. And the plus in here gives me my plus 11, so plus 11x when I multiply the two middle terms together. So that's me factorizing it. I've now got to solve it. So either the first bracket of 2x plus 11 must be equal to 0, or the second bracket, which contains x take away 4, must be equal to 0. Now on this one, it's a two-step equation, so I would take away the 11 first from both sides. So I get 2x is equal to minus 11. And then I would divide through by 2, so I could find x. So it's going to be minus 11 over 2, or minus 5.5. And in this case, if I add 4 to both sides, it tells me x is equal to 4. Now, because we want to find the length of rectangle B, going back to here, the length of rectangle B is x plus 3. Then I can't be using a negative length on these. So I can't have this as a solution. I can't have a negative length. So I need to use x equals 4. And the length of rectangle B was x plus 3 centimeters. So if I substitute x as being 4 into here now, that would be 7. So 4 plus 3 gives me 7. So the length in rectangle B is equal to 7 centimeters. Right, section 4 then is for you to show your understanding of the trigonometric graphs that we sketched in lessons. And it's really important as this non-calculator that you learn these graphs, because if you had a calculator, you'll be able to obviously work some values out, but really important to learn these. So this first graph, then, we're asking you to sketch the value of y equals sine x, and values of x go from 0 to 360. So first of all, we've got our x-axis, our y-axis. If we've got 0, we want to evenly space out really up to 360. So I call that 180 degrees, 360 degrees, got 270 degrees in between. And we've got 90 degrees here. So try and space these out evenly if you can, even though it's a sketch. Now, if you had a calculator, obviously you'll be able to type in some of these values. Sine of 0 will give you 0 on a calculator. I would just focus on like sine of 90 degrees. It's equal to 1. Sine of 180 degrees is equal to 0. Sine of 270 degrees is equal to minus 1. And the sine of 360 degrees is equal to 0. So you can start plotting out. You should already know that these lie between 1 and minus 1. So again, try and space them out evenly. So we know that our graph then, in this case, is going to go from 0 here to 1 here, back to 0, down to -1, and then back to 0. And remember, it was a nice smooth curve, like the sine wave. We call it the sine wave. So nice and smooth where you can. And back up. I'm quite pleased with that one. So this is the graph then of y equals sine x. And that's one you should learn and make sure you're familiar with. On a separate set of axes then, so I've got these ready here. We're going to sketch the graph of y equals sine x from 1. Again, the values of x go from 0 to 360 degrees. What's it actually doing here though? Well, it's just adding 1 onto your sine x value. So when we start with 0, like we did on the first graph here, the sine of 0 is 0 plus 1. So in other words, 0 plus 1 is 1. So instead of starting here at 0, where it did here, the graph this time is going to start here at 1. So it's going to start here. And again, we want to equally space out, so 180 degrees, 360. And then I put in my 270 degrees, my 90 degrees, and label my axes x and y. So when I come to doing the sine of 90 degrees, we know that's 1. And then if we plus the 1 from here, 1 plus 1 gives us 2. So at 90 degrees, the graph is going to be up here at 2. And we would do that for each of them. So at this one, at 180 degrees, it'd be 0 plus 1. So here. At 270 degrees, it would be -1 plus 1. So back to here. And then at 360 degrees, it'll be 0 plus 1. It would be here. So we can see that the graph shape doesn't change. But what happens is the graph has moved up 1 for each y value. And that's how we would draw that graph here. Familiarize yourself with the original, and then you can transform it depending on what other information you're given. I hope that makes sense to you. Okay, a bit more on graphs now then. I've got a graph here, and we can see it's a curve graph, and the graph passes through the x-axis at -2, here, and at 4, here. And it's got a maximum point at this coordinate here, 1, 3. So here is where it's at the top of the graph, and it turns back down. So we can see the shape of the graph. We are being asked here now on separate axes to sketch these graphs here, indicating the coordinates of the maximum point and the points of intersection of the graph with the x-axis. So the first one here we're going to focus on is y equals f of x plus 3. And if you remember, when we're in the function x plus 3, then we perform the inverse operation to the x coordinate. So that's what we're going to focus on for this question here. So the inverse of adding 3 is to take 3 off each x coordinate. So if I focus on this point here, the x coordinate is the -2. If I take 3 off that, it takes me to -5, 0. So this one, it only affects the x coordinate. It's in the function. So we know that this graph is going to move over, and it's going to come through here at -5, 0. If I come to this point here, The x coordinate is 4, and I'm going to take 3 away from it. So that's going to change it to 1, 0. So I'm going to come in, as it's a sketch, we haven't got to be spot on, but we can just move in where 1, 0 is. So coming in around here. And then finally, we've got this maximum point here where the x coordinate is 1. And if I take 3 away from that 1, it gives me -2. So that coordinate needs to be at -2, 3. Now I'm going to, because it's a sketch, I need to picture this. So roughly where -2 will be, and then roughly where 3 will be. So that's where my maximum point is going to be here. And then what I'm going to do is I'm going to draw exactly the same curve, but on this diagram here. So just all the way up to your maximum point, turns back down through there. Okay. And that's how we do this one. So move it 3 to the left. Okay. What about this one here then? Y equals f of x minus 2. Well, in this case here, again, it's in the function here. So we're going to do the inverse. We're going to do the inverse to the x coordinate. So we're going to do the opposite of adding taking away 2. So we're going to add 2 to each x coordinate. So again, like we did on the first one, take this one here, and we're going to add 2 this time to the -2. Takes us back to 0, 0. So we know it's going to cross through here. We go to this coordinate here. It's 4 in the x coordinate. We're going to add 2. So that's going to change that coordinate to 6, 0. I'm going to come just a little bit further over here. 6, 0. And then finally, the maximum point of the graph is 1, 3. And the x coordinate is 1. And I'm going to add 2 to it. So it's going to make a difference to the x coordinate. So it's going to be 3, 3. So I can come here roughly halfway for 3 and up, make my point. That's going to be the point here, 3, 3. And again, the graph is going to have exactly the same shape. Just need to draw a nice smooth curve. Back down through. Maybe that was a little bit better than the last one I drew. Okay, and that's how we do that type of graph transformation. Finally then, this one here. It's quite a common one on exam papers. Notice this is not in the function here this time. So this time it affects the y coordinate. Okay, what we do with the y coordinate is we do as it says here. It's like -1 lot of f of x. So to the y coordinate, we multiply them by -1. So this time we're only going to focus on the y coordinate. So the y coordinate here is 0. If I multiply 0 by -1, I still get 0. So that coordinate there is not going to change. Graph is still going to pass through here. If I go to this coordinate here for y, it's 0. Again, 0 times -1, still 0. So it's going to go through here, add 4, 0. But on this one here, the y coordinate is 3. And 3 times -1 is -3. So this time, this point here, this maximum point here now, will change and move to 1 - 3. So if I go across 1, I've got to go down to -3. It'll be around here. And that is where the graph changes on this one. It'll be a curve again. But this time it'll be upside down. And again, not to lose any marks, just put in your coordinates as been asked in the question. Right, section 6 is about surds. So there's 3 Maths Watch videos on surds here because there's different styles of and ways of simplifying a surd. So first of all, then we're going to have a look at simplifying this first one, which is asking us to square 4√5. So if we square something, then we just multiply it by itself. And when you're multiplying through these types of problems like this, I focus on multiplying the whole number in front with the whole number in front of each root. So 4 times 4, 16. And then I multiply root 5 by root 5. And when you do root 5 times root 5, then we multiply the numbers in the roots together to get one root. So 5 times 5 is 25. And the square root of 25 is 5. So if you multiply a square root with the same number in each root, then effectively you get that number without the root. So it's going to be 16 times 5, and 16 times 5 gives me an answer of 80. Okay, on this one here, then we're going to divide 4 root 20 by root 5, but I'm going to just focus on the root 20 divided by root 5. And when you divide two roots like this together, then you can just write it in one root as 20 divided by 5. And 20 divided by 5 is 4. So this is the same as writing 4 root 4. The square root of 4 is 2. So to work this one out, we just multiply 4 by 2 to give us an answer equal to 8. So as I've already mentioned about when you multiply two surds together, this time there's no values in front of either surd, so we just multiply the 5 by the 20. That gives us one root of square root of 100, and the square root of 100 is equal to 10. This, though, is like a multi-step question where we need to consider simplifying each part of this question. So I need to concentrate on squaring 2 root 5. Then I need to concentrate on simplifying 4 root 20 over root 5. And then finally, I need to focus on working out root 2 times root 8. So that's what I'm going to do first of all then. I'm going to do 2 root 5 squared. So that is 2 root 5 multiplied by another 2 root 5. And in this case, 2 times 2 gives me 4. Root 5 times root 5 is root 25. And the square root of 25 is 5. 4 times 5 gives me 20. So I know that when I come to do my final simplifying, I know that's going to be replaced with 20. Right, now then, let's focus on this 4 root 20 over root 5. And I've just showed you on the previous page, root 20 over root 5 is the same as root 4, which is equal to 2. So I'm going to skip that step there. So in this case, it's 4 times 2, which is 8. And we've just worked that one out. So 20 plus 8 here. And then the final part is this root 2 times root 8. So it gives me root 16 by multiplying 2 and 8 together. And the square root of 16 is 4. So now I've worked out each individual part, I can focus on finishing this question off now. So 20 plus 8 on the numerator is 28 over 4. And 28 over 4 is 28 divided by 4. It's equal to 7. The most important thing is, though, is to consider breaking each part down, because in an exam, by doing this, each individual component will be worth some marks on its own merit. So try and show it as I've done here on an individual basis. Okay, final section then on this preparation sheet is about probability. So it's important really that we just understand what's going on in the question. So Mr. Allen enjoys playing darts. He likes to throw his darts at the bullseye. With each dart he throws, the probability that Mr. Allen hits the bullseye is 0.3. Each dart thrown is independent of any previous attempt, and we are being asked to calculate the probability that Mr. Allen first hits the bullseye with his second throw. So for part A, if we're being asked that he hits the bullseye for the first time on the second throw, what happened on the first throw? Well, he missed it. Okay, so we need to consider he missing the bullseye and then hitting it. So that's the situation that we've got. We know the probability that he hits the bullseye is 0.3. Well, how does that help me find the probability he missed the bullseye? Well, I just take 0.3 away from 1. Probabilities add up to 1. They're the only two outcomes, hitting it or missing it, which is 0.7. And in this case, then, I know that on his first go, probability he missed it is 0.7. And to work out then the probability, so he misses and then he hits. So and in probability means we're going to multiply these probabilities together. He hits it on his second throw, so we know the probability of that is 0.3. So we work out 0.7 times 0.3. We know that 7 times 3 is 21. And we divide it by 100, so 0.21. Okay. The probability he hits it on is, for the first time on his fifth row, means he would have missed, and hit. So on this type of question, it would be 0.7 multiplied by 0.7 until we get to the first time he hits it. A bit unrealistic without a calculator. Okay, so just type that in a moment. 0.7 to the power of 4, because it's multiplied by itself, multiplied by 0.3, giving me a final solution on this one of 0.07203. But it's important you can see with these types of questions what they mean and what you need in order to perform the calculations.